Alright guys, so our next lesson is on solving quadratics. And so a quadratic is basically a function whose highest exponent is a 2, okay? And so that makes it a quadratic. There are a couple different possibilities for solutions, and they're shown down here. You could have 2 solutions, 1 solution, or no solution. And so we'll look at some of each of those. Alright, there are 4 different ways to solve a quadratic. The first is factoring. The second is taking square roots. Third, quadratic formula. And then the fourth is completing the square. And we're not going to do completing the square today, just because you really won't ever need it in this class or in calculus. But that is one method of solving a quadratic. We're going to look at these first 3 though. So anytime you see a problem, that asks you to find zeros, roots, x-intercepts, any of those things are the same thing as solving a quadratic, okay? So, first example, anytime you're factoring, in order to factor to solve a quadratic, you have to get the expression set equal to 0 first. That's the first thing you have to do. And so then, after that, you are going to, so the first thing I'm going to do right here is subtract a 3. So this is going to give me a 2x squared plus 9x, and then if I subtract that 3, that'll be plus 4 equals 0. Okay? So then I'm going to go ahead and try to backwards FOIL or factor. Alright, the first term is 2x squared, so I know I've got to have a 2x and an x. Okay, the next factor is a 4 and a 1, because I need the outsides to give me 8, and then that 1x to give me a 1 to add to give me 9. Both of these are going to be plus plus. Now, when I solve this, I'm basically setting each of the factors equal to 0. Okay, and this should be a review from Algebra 2 as well. So this is going to be x equals, if I subtract 1 over, that'll be a negative 1, and then divide by 2. So x is negative 1/2. And then right here, this is going to be x equals negative 4. And connecting it back to the last page, if we were to look at a graph of this function, this is going to be one of the ones that goes through the x-axis 2 times. So once at negative 1/2, we'll say that's there, and then once at negative 4. And so then our parabola would look something like that. Okay? And I know that it's going to be pointing upward like this, because this coefficient, the leading coefficient out front, is positive. Alright, number 2, let's factor this one. Okay, first thing I'm going to do is subtract the 4, so this is going to be 6x squared minus 3x. When I subtract the 4 from both sides, it's actually going to go away. So this one is not going to be one that I can backwards FOIL. This one is going to be one that I'm going to factor out a GCF from. And so the GCF, or greatest common factor, from these two are going to be a 3 and an x. Okay, so that's going to leave me, when I factor that out, with 2x and then minus 1. Okay, that 1's got to stay there to hold the place of the 3x. Alright, so then I'm going to set them both equal to 0, just like I did on the last one. So 3x equals 0 and 2x minus 1 equals 0. So right here, when I divide by 3, x is going to equal 0. And over here, this one is going to be x equals positive 1 when I add that 1 over, and then divide by 2 will give me a positive 1/2. Alright, so again, the graph of this one, if I were to graph it, I'm going to have a 0 that's going to go through the origin right there at 0, and then 1 at 1/2. So if this is 1 out here, 1/2's right here. And so then my parabola is going to be really small and look something like that. Alright. Number 3, the next kind of way, or the next method that you can use to solve a quadratic is by taking square roots. So whenever you do this, you need to get what's squared by itself and then take the square root. So in this one, you've got the x squared that we need to get by itself. So the first thing I'm going to do is divide by 3 to get the x squared by itself. So this is going to end up giving me, when I divide by 3, 27. Alright, Now I'm going to go ahead and take the square root of both sides. So this is going to be x equals, this is where this second bullet comes in. You've got to make sure that you put a plus or a minus in front of that square root, okay, because you've got both solutions that could work. So this is going to be plus or minus the square root of 27. And then I want to go ahead and reduce this or make it as simple as possible. So I'm going to go ahead and reduce or simplify the radical. So this is the same thing as plus or minus the square root of 27 is 9 times 3. Alright, now when I take the square root of 9, that's going to give me a 3 that I can pull out front. So this is going to be plus or minus 3 square root of 3. So then my final answer is going to be x equals plus or minus 3 square root of 3. And I would rather you leave your answer in radical form rather than put this in a decimal. Okay, so rather than plug it in the calculator and change it to a decimal. Alright, the next kind of problem we have right here is one where you can go ahead and start out taking the square root. So what's being squared? That's going to be the x minus 3. That's being squared, and so we need to try to get that alone. It is alone, so I'm going to go ahead and take the square root of both sides. So that squared's going to go away and leave me with x minus 3 equals, here I took the square root of that side, so I'm going to say plus or minus square root of 7. And then the last thing I have to do to finish this one is just add that 3 over. So 3 equals, not 3 equals, but 3 and then the plus or minus. So 3 plus or minus the square root of 7. Alright, and that's our answer on that one. And again, just leave the radical. Alright, the last way that we're going to go over of how to solve just a regular old quadratic is the quadratic formula. And the good thing about the quadratic formula is it works for any quadratic that you want to solve. So the quadratic formula, if this is your standard form, ax squared plus bx plus c, then these coefficients are what stand for these letters down here in the quadratic formula. So it needs to be, any quadratic you're going to use the quadratic formula on needs to be in standard form, which is this form right here. This is our standard form. So that means for number 5, I'm going to have to rearrange some terms to have it in the form that we need it to be in. So I'm going to go ahead and move this x squared over by adding it, and move this 3x over by subtracting it. So that's going to give me x squared minus 3x plus 9 equals 0. And now it's in this standard form up here that we can use to plug into the quadratic formula. So I'm going to go ahead and plug, a is going to be 1, since there's like a 1 in front of that, that's going to be a. My negative 3 is going to be b, and then c is going to be the positive 9. So when I plug this in, I'm going to have x equals a negative, and then b is negative 3. Okay, so I'm going to plug it in just like that. And then plus or minus the square root of negative 3 squared minus 4 times a is 1, and c is 9. And then that's all over 2 times a, which is just 2 times 1. Alright, when I go to simplify this, the two negatives at the very beginning are going to combine to give me a positive 3. And then plus or minus the square root. I'm going to simplify what's under here first. So 3 squared is going to give me 9. Minus 4 times 1 times 9 is going to give me a 36. And then 2 times 1 is 2. Alright, when I go ahead and combine what's underneath the radical, that's going to end up giving me a negative 27. And so then all that is over 2. Now, if I were going to go and try to simplify this, this is going to give me, since this gives me a negative underneath this radical, that means if I were to simplify it, I would have an imaginary number. Okay? And so what that means as far as the graph is that the graph never goes through the x-axis. Okay, it's somewhere up above or below the x-axis and never actually goes through there. So for this right here, since this would give me an imaginary solution, I'm going to say there is no real solution. We're not going to work with imaginary numbers in pre-calculus. Okay, so this is just no real solution if you ever get a negative underneath a radical. Alright, number 6. First thing I have to do is go ahead and get everything in standard form, so I'm going to say this is x squared minus 6x, and then I'm going to subtract the 7 over, so that's going to give me a plus 2 equals 0. Okay? You could try to factor it or do one of the other methods, but you're not going to be able to factor this. Okay, we can't take the square root or use square root, so pretty much the only option we have is to use quadratic formula. So I'm going to go ahead and label what A, B, and C are. A is going to be 1 again, B is going to be negative 6, and then C is going to be your positive 2. So this is going to be x equals, and I've got a negative b, so negative, and I'm plugging in b, that's going to be a negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times 1 times c. And then that's all over to a. Alright, so when I go to simplify, I'm going to have x equals a positive 6 plus or minus square root of 36. 4 times 1 times 2 is just going to give me minus 8, and then over 2. Alright, so whenever I simplify this, I'm going to have 6 plus or minus. 36 minus 8 is going to end up giving me a 28, and then that's all over 2. Okay, since I'm wanting to simplify that radical, I can go ahead and break 28 up into 7 times 4, or 4 times 7. And so then that way I can simplify that 4 because it's a perfect square. So now that I've broken that up, I'm going to have x equals 6 plus or minus. From the 4, I'm going to bring out a 2 and leave that square root of 7. Okay? All over 2. Now, because all 3 of these things right here, all 3 of these numbers, okay, so 6, 2, and 2, because all 3 of those can reduce or have a common factor, I'm going to go ahead and reduce those. Now, we could not reduce those if all 3 of them weren't there. Okay, so all 3 of those have to have a common factor to be able to reduce these. For example, if you just had 6 and 2 and this 2 was not here, you wouldn't be able to simplify this 6 and 2. Okay, it has to be in all 3 places for us to be able to simplify. So what I mean by simplify is basically just reduce the numbers. So 2 will go into all 3 of those. So 2 goes into 6 3 times. 2 goes into 2 1 time, so I'm just going to leave that square root of 7. And then 2 goes into 2 1 time, and so my denominator would be a 1, and I'm just going to leave that off since our denominator is understood to be a 1 if I don't put 1 there. And leave our answer as 3 plus or minus square root of 7. And then that would be our final answer. Alright, number 7, last one. We're going to use the quadratic formula on this one, even though you could use square roots. I'm going to use the quadratic formula. So the first thing I have to do is get everything set equal to 0. So this is going to be 6 squared minus 10 equals 0. And so this 3 is going to be my A. There is no middle term or a number beside x. So when there's no number beside x, that's kind of like this is a 0x. So I'm going to erase this just for the time being and write 0x minus 10 equals 0. And so that way I know that 3 is A, B is 0, and then C is negative 10. Alright, so when I put this into the quadratic formula, I'm going to have x equals, and then I've got a negative b, so I'm just going to write this here for now. So negative 0 plus or minus the square root of 0 squared minus 4 times a, which is 3, times c, which is 10. Okay, all over 2 times 3. Alright, so whenever I go to simplify, x is going to equal, this 0 out front kind of just goes away. Okay, so I've got plus or minus square root of, this is going to be 0, and then a negative 4 times 3 times negative 10. If you multiply all of those together, that's going to end up giving me this negative and this negative are going to multiply to make a positive. So this is like 0 plus, and then 4 times 3 times 10 is going to be 120. So really, I've just got a 120 underneath that radical. Alright, and then 2 times 3 is 6. Now, when I go to split this up, or the 120 up, I've got to find a perfect square that's going to go into it evenly. So the biggest perfect square that's going to go into 120 evenly is going to be 4. And I would say 4 times 30 would give me 120. So then, by breaking it up like that, it's going to allow me to say this is a plus or minus. From the 4, I can bring out a 2. So plus or minus 2 square root of 30 all over 6. Now, because there is no number in front of this plus or minus, I can go ahead and reduce the 2 and the 6 here, since they both have a common factor. And so then whenever I reduce that, that's just going to be plus or minus. 2 goes into 2 one time, so that's just going to leave me with square root of 30. And 2 goes into 6 3 times. And so then that would be my final answer in the reduced form. Alright, 2 more. On this one is one that is similar to problems that we did in the first lesson. Okay, these are just going to end up giving us a quadratic to solve it again. So this is one where I need to multiply by the least common multiple, and the least common multiple on this one is x minus 1. So I'm going to go ahead and distribute that x minus 1 to all 3 fractions. So over here, on the first x, I'm going to get x times x minus 1 plus, this is going to end up being 3x times x minus 1, and I'm going to put it over x minus 1. And then equals x plus 2 times x minus 1 over x minus 1. Alright, so now when we do the least common multiple or distribute it, I should end up getting my denominators to cancel. And so those cancel, and this is what I'm going to be left with. X times x minus 1 plus 3x equals x plus 2. And the reason that these are in the quadratic section is because whenever we go to distribute this x, it's going to end up giving us a quadratic. And so we'll have to use one of the 4 methods that we just learned how to do, or reviewed how to do, to solve this once we distribute. So this is going to be x squared minus x plus 3x equals x plus 2. So I'm going to combine like terms on the left. So x squared plus 2x equals x plus 2. And then I'm going to go ahead and subtract the x over. So this is x squared plus x. And I'm going to subtract the 2 over. So minus 2 equals 0. And then I'm going to always try to factor or backwards FOIL first, just because that's typically the easiest way to go about doing it. So I'm going to backwards FOIL this. So this is going to be x and x. It's got to be 2 and 1. There's no other option. Plus 2 minus 1 equals 0. So then I have 2 solutions for this quadratic. I have x equals a negative 2 and x equals a positive 1. Now, on this one, you need to make sure, since we did have denominators, okay, we need to make sure that none of our answers are going to give us something that's undefined. So if I go back up here and check, if I plugged 1 into the bottom of these 2 fractions right here, it's going to give me 0 on the bottom, so it's going to give me an undefined solution. So I don't want that x equals 1. My only solution is going to be x equals a negative 2. Alright, I'm going to go ahead and say you should pause the video at this point and try number 9 on your own, and then see what you get, and then watch me do it and check it. Okay, so you can have a little bit of practice in there and try number 9. I'm going to go ahead and do it, but you guys can pause it and then come on to number 9. Okay, so for number 9, I'm going to go ahead and backwards FOIL this right here so I can see what my LCM, or my least common multiple, needs to be. So this is going to be x and x. It's got to be 4 and 2. Both of the signs have to be minus. So that's convenient because they match my first two denominators on the fractions, on the first two fractions. So the least common multiple is going to be an x minus 4 and an x minus 2. And I'm going to go ahead and distribute that out. So this is going to be x times x minus 4 times x minus 2 all over x minus 2 plus 1 times x minus 4 times x minus 2 over x minus 4 equals 2 times x minus 4, x minus 2, x minus 4, x minus 2. Okay, so now that we've got that distributed out, all the denominators should cancel. So x minus 2's are going to cancel, x minus 4's are going to cancel, x minus 4's and x minus 2's are going to cancel. So I'm left with this. X times x minus 4 plus 1 times x minus 2. I'm just going to go ahead and write that x minus 2 since the 1's not going to change it. And then equals 2. Alright, so I'm going to distribute the x, which will make this an x squared minus 4x plus x minus 2 equals 0. And then let's go ahead and combine like terms. So I'm going to combine these middle x's here to give me x squared minus 3x minus 2 equals 0. So then the easiest way to solve this one is to try to factor or backwards FOIL again. You could use quadratic formula if you wanted to. That's a little bit more complicated, I think. But we can go ahead and try to backwards FOIL. So this is going to be x and x, 2 and 1. And then this is going to end up not working. I forgot that 2 over there. Alright. So this is a 2. So whenever I combine these like terms, that is going to give me x squared. This is going to be minus 3x. But I'm going to go ahead and subtract this 2 over. Okay, so this is going to be a minus 4 equals 0. And now that looks better, and that's something that we can factor. So for this one, I'm going to factor it into x and x again. And then the 4, the 2 factors that I'm going to need are 4 and 1. Those are the only ones that will combine to give me a 3. So I need a minus 4 and a plus 1 equals 0. And so then this is going to mean x equals a positive 4 and x equals a negative 1. And so then if I go back up and look at my answers, that positive 4 is not going to be able to work because if I plug it in, that's going to give me something undefined right here and right here. So then this solution is not going to work. That means x equals a negative 1 is my only solution that works. Okay? And then in the next video, we'll go ahead and talk about quadratic types. So we'll start here in the next video.